spiral eddies, you know, now that the threat is gone, spiral eddies are really a key to all this stuff that they're trying to do about climate change. See, one of the biggest things in the models that they're doing on changing climates is the influence of the ocean, or the interchange between the ocean and the atmosphere. It's very difficult to model the ocean. And so what they do is that they model a mean ocean temperature, and then they forget it. And they may change it every, you know, as they're running their model year by year by year by year, they have enough capability to change the ocean temperature twice a year, summer and winter. But that's it. And but now here are these spiral eddies. You see, they're at the surface. They're spiraling cyclonically, which means there's cold water in the center. They're not turning because there's cold water there. They're turning because there's some force that's created them, so they're bringing the cold water to the surface. So if you're out there measuring the ocean temperature, then if you happen to measure in the middle of a spiral eddy, which you're not going to see from a ship or whatever, then that water is that temperature, but over here it ain't, 15 miles away. And but when you get so many of these things, you know, people say, oh, well, you know, they're just 15 kilometers in diameter or 30. What difference does it make? Well, you get these whole fields of them covering a major portion of the ocean, and therefore they're a major difference in the temperature of the sea surface, and you must account for that. But you can't do it because, number one, they're ephemeral. You know, the whole field may be there all the time, but they are not there. And so what is therefore the difference in temperature that they create? And, you know, there's no way that these models can possibly address that. Furthermore, those eddies are bringing water up from 100 meters or 150 meters, whatever it is. That water is much different than it was at the surface because there are a lot of beasties down there that, as John Young, well, I won't say that, but there are a lot of beasties down there which eat up the carbon dioxide, right? So this water in the center of the spiral eddy is lower in carbon dioxide than surface water would normally be. And therefore, if there's a field of spiral eddies, which there are all the time, they represent a carbon dioxide sink, that is, carbon dioxide going into the ocean, which has not been and in their models is not addressed. And so all this mystery about, see, there's a big mystery. They cannot account for the CO2 that's produced by man, or by women too, but I mean, you know, they cannot account for where 50% of it is. When they measure CO2 in the atmosphere, it's only half. You know, if they take this CO2 that's up there, then man's producing this much, which is going up there. That amount cannot be found in the atmosphere. So it's got to go somewhere. So this is a big deal. They're looking for sinks. Recently somebody said, oh, well, the forests in the northern hemisphere are grabbing it all up, and you know, and people growing orchids in Hawaii, they're you know, they don't know where it is. And since they've measured the ocean on a broad basis, they say, well, the ocean temperatures, you know, that determines how much CO2 can be drawn in, but that ain't it, see? But the spiral eddies are creating a circumstance, or a situation, is very difficult to determine, because the eddy that you measured right now is not there, you know, probably 4 hours from now. There's another one there. And this whole field is moving around just like smoke in the breeze, smoke rings and all that sort of thing. They exist. There's probably, roughly, we figured, there are probably 5 million spiral eddies rotating in the world ocean continuously somewhere, so they represent a major part of the ocean. So from the point of view, from the navies, that's bad news. From the guys who are worrying about climate models, it's impossible. Forget it. I don't even want to talk about it. But the model isn't good. The models aren't any good anyway, or not very good anyway. But they cannot ever be anywhere close to being precise until they can account for that continuous change in temperature. It's either going to have thermal energy going up, or it's going to have thermal energy going down, and then you can't do anything unless you know that.